Good afternoon, everyone. Guys, how are you today? I hope that you're doing well. For tomorrow, we're gonna start with the new subject, which is about the physical properties of matter. The physical properties of matter, maybe it's not new for you, but maybe you have information about this topic, but still in this book, I'm gonna explain for you about the physical properties of matter. Let's write down about the page. It's page 228. If you wanted to bring your book with me with the notebook and write with me what I am explaining. Guys, in the physical property, before we explain about the physical property, we have to know what is a matter. Matter is anything or everything that take up space, Okay, is everything that take up a space, or is anything that take up space? What do we mean by this? I have this pen and I'm gonna put it this one. I can call this one as a matter. Why? Because it take up the space. It makes, like, let's say that this space, it filled this space. It filled this space. If I'm gonna bring another thing like my eraser, I'm gonna put it here. Sorry, I'm gonna put the eraser here. Okay, the eraser here. Also, I can call the eraser as a matter. Why? Because it take up the space. So everything which take up the space. Okay, even my glass of water, it take up the space. Why? Because it fills the space of here. So I can call it as a matter. Everything that take up the space, I can call it as a matter. But there are something. Okay, if we write down example, I can say that, let's say book, let's say computer, anything which take up the space, I can call it as a matter. But do you think that there are something which is like we cannot call them, let's say that they are not matter, because not everything are matter. Not everything that has mass and take up the space. It means not everything. For example, it gave us an example, rainbows. We can see rainbows and we can feel it, but because it doesn't take any of the spaces, it doesn't have mass. So when something has a mass, it means that it take up the space, right? Take up space. Okay, so everything which is like they have mass, we can call them that they can take up the space. Okay, but not everything, and not everything has a mass. As we said, it gives an example of rainbow, charge, sound, and for example, do not. So these are examples that they don't have masses: rainbow, charge, sound, or we can say smell. These things that we can only feel, they don't have the mass because they don't take up the space. Yeah, they are not made up of matter, although marbles, bicycle, and trees are all made up of matter. Okay, we know that. Okay, let's talk about the physical property of matter. Now we know that what is matter, so it take up the space of everything, which is take up the space. But what about the physical property? What is the physical property? Okay, so here we have the definition of a physical property. I'm gonna highlight with you directly with the let's say that with the definition. We are starting with the definition of the physical property. Physical property, properties that can be observed or measured without changing an object or any of the matters it's made of into something else. Yeah, okay, I'm gonna highlight the definition, and you can memorize the definition of physical property. Properties that you can see that, like, now I have a lot of the highlighters. See, I've got a lot of them. I don't know, I have a lot of them. Okay, properties can be observed or measured without changing an object. For me, until here is enough for to memorize the definition. The other one is extra. So I'm asking you only to memorize this definition of physical property. Properties that can be observed or measured without changing an object. What does that mean, guys? It means that now I can see my highlighter, right? So I can say about the properties of this this highlighter. I can say that it has a green color, and with the black one it look like little bit long. I can say the physical property that I can see directly. Yeah, so this is, I can say this is a physical property, properties that can be observed or measured without changing an object, like without changing this let's say this marker. I can see the physical properties of this of this highlighter. Yeah, okay. Or any of the matters is made of into something else. Even some substances have physical property that can be used to identify. Okay, so some of them, some of the properties such as mass and size. Okay, what mass, it means that if this is very, let's say that heavy or it's light. And size, I can say that if this one is small or big, right? For example, I can say that this one, this one is longer than this one, but maybe this one it will be more heavier than the pencil. So in the physical property, also I can say that I can measure them, and I can say this one is heavier than this one, and I can say that this one is longer than this one. Yeah, this is the examples of physical property. Okay. Can change according to how much of the substance is an object. Other physical properties of a substance never change. Okay, so we say that some of the physical properties such as mass and size, they can be changed. So now we're gonna highlight this one. Some of these properties such as mass and size can be changed according to how much the substance is in an object. Okay, I'm gonna change my highlighter with another one. Other physical properties of the substance never change. These never change, like what? Color, smell, attraction, magnet, melting, boiling point. Yeah, okay, they will never change. Okay, as I said to you guys, I cannot change, for example, I can change the mass and the size of a substance. How? I have this marker and I'm going to put it on the balance, but I'm going to put another one. Yeah, so I changed the balance, I changed the mass, the weight of this highlighter. I make it to become heavier. But can I change the color of, let's say that I have orange. No, I have an apple. Can I change the color of an apple? Have you ever seen the apple with the, let's say the black one? Or can you change the color of the apple, which is like, let's say that if it's yellow, can we change the color of the apple, which is yellow, to become, let's say that white? No, I cannot do that because this is something natural. White. No, I cannot change it because this is something natural, right? So smell. Can I change the smell of, let's say that, can I change the smell of watermelon? No, I cannot. I cannot do that. Why? Because this is the original one. I cannot do anything with the smell. Even the attraction to magnet. If I have this one, and if I will have another magnet with this one, I cannot change this one to, let's say that, to not be attracted by the magnet. Why? Because this is a metal. This is the property of this iron, which is metal, so it will be attracted with the magnet. Magnetic. I cannot change the property of this one, right? Okay, as I said, these are, I can change it. Mass and size, I can change it, right? But about these, I cannot change it. Color, smell, attraction, magnetic, melting and boiling point. What do we mean by melting and boiling point? Guys, as we know that if I put this water on the boiling, right, on the boil, after a while it will become, let's say that it will become 100, it will become very hot, right? And if I'm gonna put this one in the freeze, it will, let's say that it will become freeze. It will freeze. Why? Because this is water. This is one of the properties of water, of matter. When I put it inside of the freeze, it will freeze. If I'm gonna put on the boil, it will become boiled, right? It will become very hot water. So anything in the life, it has any of the matters, it has the properties of something. Some of them we can change it, like mass and size, but the others we cannot change it. If I ask you, give me 2 examples of property of matter that can be changed. Yeah, you're gonna say to me mass and size. If I ask you, give me 2 examples or 3 examples that can never be changed, you're going to say to me color, smell, attraction, magnet, melting, boiling point. Yeah. Okay. Except of these things that we talked about, that guys, we have more properties of the physical property of matter. The first one is like texture. Let's see that what is a texture. Okay. Physical property that can be used to identify a substance is the texture. What is a texture, Ashley? Texture is how the surface of a substance feels. How the surface of the substance feels. For example, the surface might be rough or smooth. Okay, I have got an let's say that an example for you. Okay, this one I can touch it, which is look like very, very rough. Even if you are with me, I could give you to touch, it's like rough. But if I will give you another example, which is has a smooth, this eraser, I touch it, I can feel it, it's very, very smooth. But this one is the, let's say that this one is rough. So texture, it shows you how this one is smooth and how this one is rough. As I said, we can feel them because they are like a physical property and they are outside, we can touch it. This is smooth and this is very rough. So this is, let's say that texture is how the surface of a substance feel. I can feel this one is like rough and this one is very, very smooth. Yeah. Okay, this is about the texture. Okay, another property that can be observed are malleability and ductility. I don't know you remember about that, we explained about malleability and ductility, but still I have the video that I showed you of malleability and ductility. Guys, in this video I prepared one of the videos that I showed you last time, but still we're gonna see it if it's it only to remind you about malleability and ductility. Be with me until you're gonna see a short video.
Metals can be drawn into wires, flattened into sheets, and molded into different shapes. Metals are malleable. Malleability refers to the property of a metal that allows it to be beaten into sheets. Ductility refers to the property of a metal that allows it to be stretched or drawn out into wires.
Okay, so as you can see, this one, this metal, anything that we can make it like a sheet, as you can see, this one is look like a sheet, we can call it as malleability. So I cannot break down easily this one. Why? Because this is this is metal and we can make them to become like a sheet. So I can make this one as a sheet, I can call this one as one of the properties of matter, which is malleability. Another property of matter that we can call it as ductility. So not matter actually, another property of metals is ductility. So I can make the metals to have such as the wire. So anything that you can see such as a wire that cannot be easily breaking down, I can call this one, this is another property which is ductility. So if I can make this one as a wire, I can call it as ductile. If I can make this one as a sheet, I can call it as malleable. Yeah, let's see, let's go back to the definitions of each one of them, and we're gonna be continue. So what is malleability? Is the ability of a substance to be bent, hardened into a thin sheet, or otherwise shaped without breaking. So as I said, I make this one, this metal to have a sheet, to have a shape of a sheet, so I cannot break down this one easily. Can I break down with my hand? No, I cannot. Only if I have something very strong, maybe I can, let's say that I can break down, or under very high temperature, maybe I can make it to become another shape. And let's go back to the ductile. What is ductile? Is the ability of a substance to be pulled into thin threads without breaking. So I can make this one as a wire, so it has a wire shape, I can call it as ductility. Okay, so let's go back to the highlighting. We're gonna highlight the definition of the texture, malleable and ductile. Guys, I highlighted the first definition of physical property with the blue one, so I'm gonna highlight with the same color, which is the blue. You are free to highlight it with another color. What is a texture? Okay, is how the surface of a substance feels. This is the definition. If I ask you to give me an example, you're gonna say to me the surface might be rough or smooth waxy or powdery. Yeah. So this is the definition of texture, and with the examples. What is malleability? Is the ability of a substance to be bent, hardened into thin sheet, or without shaped without breaking, or otherwise shape it without breaking. This is the definition of malleability. What about ductility? Is the ability of a substance to be pulled into thin thread without breaking. So guys, as you know that the definition is, you are responsible to memorize them. Please memorize the definition of each one of them, because be sure after the lesson I'm gonna ask you if you saw the video or not. Yeah. Okay. Many metals include gold, have ductility, and so can be worked into fine design and ornaments. A substance that has the property of both. A substance that has the property of ductility is said to be a ductile. Yes, we know that. Okay. The opposite of both malleable and ductile is brittle. So this is the opposite of both of them, malleable and ductile. Guys, as we know that malleable and ductile mostly we are using for the metals that we cannot be break down easily, But brittle, maybe it can be break down easily, which is the opposite of malleable and ductile. Okay. We have another thing which is let's say that is volume. What is volume actually? An important physical property that can be calculated from measurement is density. Okay, so we know that now density is another property of physical property of matter. So if we are writing down some of the physical properties of matter, the first one we are writing down texture. Okay, let's write down physical properties of matter. Physical properties of matter. The first one, as we write, the first one is texture. The second one I'm going to write for you here. The second one, malleability. Third one I'm going to write for you, ductility. And number 4, we can write it as a density. Okay, let's see that what is a density. Density, here's the definition. Let's highlight the definition, and then we're going to read about the density. Is the amount of mass that fits in a given volume. The density of an object is found by dividing its mass by its volume. Guys, if I give you only one example about the density, only to understand better, I have this water, okay, and as they measured its mass and it fits in a given volume. Okay, if I have two substances like this, this is only a paper, okay, with the another one which look like metal, this one that I showed you, which is like a sheet of malleable. Okay, if I'm gonna put both of them here, which one will sink and which one will float? Yeah, I know you know the answer. Still, you're gonna say to me, because this one is heavier, it's gonna float. Why? Because this one is heavier, right? So the relation is between mass and volume. So this is, I can call it as density. Is the amount of mass that fits in a given volume. The amount of mass. This is the amount of mass. How much this mass is heavy or is light. The amount of mass that fits in a given volume. So because this is water, so I can use a volume for water, right? You know that for anything liquid, we can use it as we can use volume. For anything which is look like, let's say that they have mass, we can call it as so I can use this one, I can use mass for this one. Why? Because it's not look like a liquid, it's look like a solid. So for the solid parts we can use mass, and for the liquid parts we can use it density. Okay, after density, guys, we have another sorry, just make it okay. After density, so the density is a relation between mass and volume. Between mass and volume. As I said, for the solid parts we are using mass, but for the liquid parts we are using a volume. Okay, let's continue with another property. Okay, the density of a gas is more variable. The density of a substance determined another its physical property is buoyancy. So what is buoyancy? Is the ability to float in a liquid or rise in a gas. A substance is buoyant if its density is less than that of a liquid or a gas. Okay. The number 5 we are writing down buoyancy. Okay, as I said to you, this is water, so now we're gonna do the practical way, the practical. Okay, I've got both of them. I'm gonna put both of them inside of the water, and I will see that which one will float, which one will sink. If I put the water, nothing will change. Like if I put the paper inside of the water, nothing will change. But while I'm putting this one inside of the water, as you can see that directly it will go inside of the water, right? So it's here and this one is here. So I can say that this one is very light, but the other one is very heavy. Why? Because the mass of that iron or that metal, the mass, let's say that it has a bigger mass than this one. So this one we can call it float, and this one we can call it sink. Why? Because it's this one is at the top and this one at the bottom. Okay. So we have let's to highlight the definition of buoyancy, which is the last property of physical properties, and then I will give you some examples about this. So buoyancy is the ability to float in a liquid or rise in a gas. A substance is buoyant, so the definition is until here. A substance is buoyant if its density is less than that of water. So this is not the definition, only that part, sorry, only that part is the definition, but the other one is extra. So I'm gonna maybe I'm gonna make it like this, sorry, because I made a mistake. So, and the definition until here is the ability to float in a liquid or rise in a gas. Yeah, this is the definition of buoyancy. As I said, when we are putting something inside of the water, if it's like if it will float or if it will sink. We have some examples, like the first one is helium and gives the density and buoyancy. So helium, this is the density of a helium, which is very light, as you can see by comparing with the other one. So helium, because helium is like a gas, but it floats in a pure water. Why? Because it's the density is very small. But if we compare it with mercury inside of the water, it sinks in pure water, right? Because it's, let's say that the density is 13.6. So guys, you don't have to memorize the density. You don't have to memorize them. Only what you're gonna do it for me. Olive oil. What about olive oil? It will float in a pure water. Why? Because the olive oil, if you look at the density, it's like 0.9. Even it's not, let's say that even it's not 1. But pure water, we don't put pure water inside of the water, because water is water, like they're the same. Diamond is 3.5, it sinks in the pure water. Lead is 11.3, sinks in the water. So how are you going to see this one in the exam? I will give you a question, and I'm going to say to you, is helium sink in a pure water or it floats? So you will see the schedule. You're going to see that it floats in a pure water. It will not sink. Why? Because it's very light, right? So what are you going to do it for me? You will just memorize them with this one. It's easy. If I say to air, you're going to say to me floats in a pure water. If I say to wood, you're going to say to me float in a pure water. What about if I say pure water in a pure water? You're going to say to me nothing will change, right? Because they are, both of them, they are water. Diamond, you're going to say to me sinks in the water. So these three, they're going to sink in the water. These four, they're going to float in the water. Pure water, nothing will happen. Yeah. So this is about the video of today. Please highlight the things that I highlighted, and don't be worried for the homeworks, I will give you the homework, and I'm gonna write for you. Thank you very much.